Today we're going to spend some time on real-life applications of sinusoidal functions, which sounds like a strange thought right there, but we have a Ferris wheel that is modeled by the function h at theta equals h sine theta minus 45 plus 10. So this is a description of the height depending on how far we've rotated around from the beginning. Ferris wheel's height is definitely modeled by a periodic function. We go from low to high to low to high over and over again. And we also hope that it's smooth like a sinusoidal function. So this is a very good model for the height. First question is, what does the 10 mean in terms of the Ferris wheel? So I know mathematically that that 10 is a vertical translation up 10. That means that the middle is no longer at 0. The middle is 10 meters in height. And that makes sense. If the middle were on the ground, the Ferris wheel would dig in under the ground, and that just doesn't sound safe. So physically, in terms of that Ferris wheel, it means the middle of the Ferris wheel, or the axle where it turns, is 10 meters up. We've really answered the B part already. The 10 means in terms of transformation, is a vertical translation up 10. We've been asked to sketch the function. So we are going to do this as a series of transformations because it's good practice. Okay, here's our equation. Please don't be afraid of the letter theta. It's just a Greek letter. You seem to like x a little better. But anyways, and h at theta means y. So we've seen this before. This is a sine curve. So we know that it starts in the middle, goes up, back, down again. So what do I know? First of all, I know that it's been moved up 10. I know that this 8 is the amplitude, or the vertical stretch factor 8. I know that it's not upside down, so it's going to start in the middle and go up. And I see lastly that we have a horizontal translation 45 to the right. So when I set out my grid, I can put the axis fairly low because this Ferris wheel is not going to go in under the ground. So instead of x, I'm going to call it theta. My height, I know, so I'm cheating a little bit. So h at theta, which is the same as y, my height. So angle of rotation. How far is that Ferris wheel turning? Height. Okay. I do know, so I'm cheating a little bit. I know the middle is going to be at 10 because I'm moving it up 10. I also know it's going to go 8 above that and 8 below that. So I need numbers. I'm going to try and hit a height of 20. That should cover things as well. So 2, 4, 6, 8, 10. This should work. So I'm going to go up by 2s. That should fit fairly well. Now as I do my horizontal axis, I am in degrees. I know one complete cycle takes 360 degrees, but cheating a little bit as well. I know that I'm going to move it to the right 45. So it would be really helpful if 45 were 1 or 2 squares. I'm going to make 45 2 squares so that we can see it well. So I'm just spreading this out a little bit. Okay, so here we go. So I have a sine curve. I'm not going to do this as a series. I'm going to try and do it in just 2 sketches. But I have a sine curve that's been moved up 10, so I know that my axis will be at 10. I'm just marking that. And I know the amplitude is 8, so 8 above and 8 below. So I'm going to do those 2 pieces. I'm not going to do the right 45 yet. So I'm going to do 8 sine x plus 10, just to make sure my sketch makes sense. So I'm going to start in the middle. I'm going to go up to my highest, which is 8 above the middle. at the 90-degree mark. I go back to 0 at 180, or at the middle at 180, and I go to my lowest, which is 8 below the 10 at 270. Back to my middle again at 360. So I haven't shifted this to the right yet, but I've done the other two transformations. All right. So that Ferris wheel does not hit the ground. Thank goodness, nobody's going to get hurt. It's 2 meters above at its lowest point, and it's 18 meters above at its highest point. So I'm just checking that I've got my amplitude. Above 10 is 8 and below 10 is 8. We're good. The middle is at 10. Okay. Then we are moved over to the right 45. So on my graph, that would be 2 squares. So I mark my key points. 2 squares to the right. All right, I'm going to just fill this in backwards a little bit there. That's not perfect, but we've got the basic shape of this graph. So we've talked about some of these things in order to graph it, but it asks us, what is the amplitude of the function and what does it represent in this situation? So the amplitude is the a value in our transformed equation, and it was 8. I also checked on my graph that I went 8 above the 10 and 8 below the 10. That is an amplitude of 8. What does that mean in terms of this situation? It means that the maximum is 8 above the 10, which would be 18, by the way, and the minimum is 8 below the middle, which is 2, by the way. And in terms of the Ferris wheel, it means its radius is 8 meters. When an individual has rotated 200 degrees from the boarding position, how high above the ground is that individual? So I am asking you to find height when I give you theta. So I'm giving you an angle. I'm asking you to find h. So we're going to solve our equation by substituting theta equals 200. So notation would be h at 200 equals, so I'm just getting a y value here, 8 sine, it's 200 that I put in here, plus 10. So we need a calculator. We need to make sure it's in degree mode. So when I have typed it into my calculator, I get approximately 13.8 meters. Let's look on our graph and see if that makes sense. So at 200, 13.4. So here is 200 degrees, close to here, and my height of the green one at about 13.4. Certainly reasonable. The last question asks us, how far has the Ferris wheel rotated when an individual is 7 meters above the ground? So we have been given the height. We are asked to find an angle of rotation. So this is answering a different question. I have been given the height. That's my h value. And I want to solve for theta. So this is some really good solving skills that we've been working on over the semester. Here we go. If I want to get theta by itself, I need to get rid of the add-ons first. So I'm going to subtract 10 from both sides. If I want to get theta by itself, the next thing I need to get rid of is multiply by 8. So I'm going to divide both sides by 8. Notice I haven't approximated anything yet. Okay. If I want to get theta by itself, the next thing I need to get rid of is the word sine. The opposite function to sining something is inverse sining something. And last, before I even touch a calculator, If I want to get rid of subtract 45, I'm going to add 45. So in my calculator, I'm going to take the inverse sine of minus 3/8, and then I'm going to add 45. The answer that I get on my calculator is approximately 22.97, so approximately 23 degrees. Let's have a look at our graph and see if that makes sense. So when is the height 7? Okay. So very, very approximately. The height is 7, 2, 4, 6, 7, about right there. And it says that's about 23 degrees. That is reasonable.